sum to infinity of a geometric progression is 7, and the sum of the first two terms is 48 over 7. Show that the common ratio R satisfies the equation 1 minus 49R squared equal to 0. Hence, find the first term of the geometric progression with positive common ratio. From the question, we have the information S infinity equal to 7, and the sum of the first two terms S2 is equal to 48 over 7. So the question wants us to show the common ratio satisfied the equation 1 minus 49R squared equal to 0. Now we're going to use the formula for S infinity, A over 1 minus R equal to 7, and we cross multiply A equal to 7 minus 7R. So this will be the first equation. The second equation we can get from S2, A multiplied with 1 minus R to the power of n over 1 minus R. So we substitute n equal to 2 and equal to 48 over 7. So A 1 minus R squared divided by 1 minus R. So equal to 48 over 7. Next, we can factorize 1 minus R squared. We will get 1 minus R multiply 1 plus R over 1 minus R equal to 48 over 7. And we can cancel 1 minus R here, and left A multiplied with 1 minus R equal to 48 over 7. So this will be the second equation. Equation 1 into equation 2. So 7 minus 7R multiplied with 1 plus R equal to 48 over 7. And we expand the equation. We will have 7 plus 7R minus 7R and minus 7R squared equal to 48 over 7. And simplify, we'll get 7 minus 7R squared equal to 48 over 7. Next, we're going to cross multiply the equation. So we'll get 49 minus 49R squared equal to 48, and 49 minus 48 will get 1 minus 49R squared equal to 0. So from here we get the equation that satisfies 1 minus 49R squared. So we can show here. Next, find the first term of the geometric progression with positive common ratio. From the equation, 1 minus 49r square equal to 0, we can factorize the quadratic and we will get 1 minus 7r and 1 plus 7r equal to 0. So we want to use the positive common ratio, and we use 1 minus 7r square equal to 0. So 1 equal to 7r and r equal to 1 over 7. So from here we're going to substitute r equal to 1 over 7 into equation 1, 7 minus 7r. And we will get a equal to 6. Next question, express each of these number as a quotient a over b. So the first rational number 1.6 with the Vitellius sign up there. Vitellius means a oval line that represent a repeating decimal number. So for 1.6 here, it means 1.6666 and so on. Okay, so we want to change 1.666 into a quotient or fraction. So let's separate first the number. To get this 1.666, we can represent it as 1 plus 0.6 plus 0.06 plus 0.006 and so on. Now we take just this part, 0.6 plus 0.06 plus 0.006 and so on. We can write it in this form: 0.6 multiplied with 1 plus 0.6 multiplied with 0.1 plus 0.6 multiplied with 0.01. And we know that here is 0.6 is multiplied with 0.1 to the power of 0 plus 0.6 multiplied with 0.1 power of 1 and 0.6 multiplied with 0.1 to the power of 2 and so on. From here we get the information A equal to 0.6 and common ratio 0.1. So let's find the sum. 0.6 over 1 minus 0.1, so is equal to 0.6 over 0.9, and we simplify, we will get 2 over 3. And now we can get the value for 1.6. Here is 1 plus 2 over 3. So 1 we take back the value from here, and it's equal to 5 over 3. And you can check back the value for 5 over 3 is equal to 1.6666 and so on here. Next we're going to find the quotient form for 5.459. repeating for 5, 9 there. Okay, so from here we can write the series in the form 5.4 plus 0.059 plus 0.00059 plus 0.0000059 and so on. Okay, now we just take this part 0.059 plus 0.00059 and another one 0.0000059. So from here 0.059 plus 0.059 multiplied with 0.01 and plus another one 0.059 multiplied with 0.01 squared and so on. And the information we get here, E, the first term, equal to 0.059 and common ratio R equal to 0.01. So the sum infinity is equal to 0.059 over 1 minus 0.01. So we calculate the value that we get here is 59 over 999 and we can get the quotient form for 5.459 is equal to 5.4 plus 59 over 990. So total up we will get 1081 over 198. And we can check back the answer. Try to calculate 1081 over 198 and we will get 5.4, 59, 59, 59 and so on.